Picture this, you're sitting in your Cambridge 9700 biology exam. You flip to question 2 and boom, it's on a topic you've literally revised for hours, 2.2 phospholipids. You're thinking, yes. You write down every single thing you know about hydrophilic heads and hydrophobic tails, and you walk out feeling absolutely confident. Then, 6 weeks later, you get your results and you completely miss the mark band. What on earth happened?
Seriously, why do students who know the biology perfectly, like people who could draw a phospholipid molecule blindfolded, still drop entire grade boundaries on these specific questions? Well, it usually boils down to a tiny, devastating mistake. A mistake that costs you marks before you even realize what the examiner is actually testing you on. So in today's explainer, we're going to fix exactly that.
And this quote right here brilliantly illustrates the brutal reality. Straight from the Cambridge Principal Examiner report, they say, the classic mistake is providing generic answers not specific to the question context. See, this is exactly why ordinary revision fails. You memorize the textbook, you give a textbook answer, and the examiner gives you 0. Why? Because you didn't link your biological knowledge to the specific experimental scenario given in the question. The stakes are just way too high for generic answers.
All right, moving into section 1, core concepts, phospholipids unpacked. Let's get into it. To totally master this exam strategy, we first need to make sure our foundational knowledge is completely airtight. It all starts with the hydrophilic head. This is the water-loving phosphate part of the molecule that naturally interacts with the aqueous environment, both inside and outside the cell. Now, it's a super simple concept, but examiners expect you to use precise terminology here, like saying aqueous environment rather than just water, when you're describing how it behaves.
Now notice the stark contrast here. Attached to that hydrophilic head are the hydrophobic tails. These are the water-fearing hydrocarbon chains that orient themselves inwards, actively pointing away from water. This exact structural duality, heads pointing out, tails pointing in, is basically the engine behind how membranes function. And more importantly for us, it's the specific mechanism you are going to be tested on.
Oh, and before we move on to the heavier exam strategy, here's a really quick win for your revision. Try creating a memory hack for the 2.2 phospholipids topic. Just grab the first letters of your key terms, hydrophilic, aqueous, hydrophobic, hydrocarbon, bilayer, and build your own mnemonic out of them. Doing this actually saves you a ton of cognitive load during the exam, meaning you can focus your brain power on answering the actual scenario instead of just trying to recall words.
Now, in just a moment, I'm going to show you the exact examiner clue that changes your answer completely. Literally a clue that dictates whether you get full marks or 0. But first, you need the analytical framework that's going to make that clue entirely obvious to you the second you read the paper.
Which brings us to section 2, the method marks strategy.
So the crucial thing to understand is that Cambridge isn't just testing your ability to recall facts like a robot. They are testing your reasoning. Here is the exact sequence examiners are looking for if you want top-tier answers. Step 1, identify the concept. So in our case, phospholipids. Step 2, extract the evidence or data that's provided in the exam prompt. Step 3, apply scientific reasoning to actually connect that concept to the data. And finally, Step 4, present the whole thing using the exact examiner wording expected in the syllabus. If you skip Step 2 or 3, boom, you lose the method marks.
Let's see how this builds when we introduce experimental data. Because let's face it, that happens constantly in 9700. When you're handling and evaluating information about membranes, you absolutely need the right statistical methodology. You're going to use a t-test for comparing means, chi-squared for categorical data, and correlation tests for relationships between variables. Knowing exactly which test applies to the evidence in front of you is a massive part of pulling off that method mark strategy.
But, even with the right framework, students still manage to fall into some really common traps. Here are the top 3 examiner warnings directly from the principal examiner reports. Number 1, forgetting to include units in calculations. That literally throws away easy marks. Number 2, forgetting to double-check those units and your biological terminology. And number 3, which is honestly the biggest killer, giving answers that are not specific to the context given in the question stimulus.
Okay, section 3, spot the error challenge. Let's do this.
It's time to shift gears and put this into practice with a quick challenge. Take a look at this student's answer. It says, the heads like water and the tails don't, so they form a bilayer. Now, at a middle school level, yeah, this is factually true. But on the 9700 biology paper, this scores exactly 0 marks. Why? Well, because it's entirely generic, it completely lacks scientific reasoning, and it totally ignores the required syllabus terminology.
Now compare that flawed answer with a true top-band response. Listen to this. Hydrophilic phosphate heads interact with the aqueous environment, while hydrophobic hydrocarbon tails orient inwards, forming a selectively permeable bilayer. I mean, just look at the massive terminology upgrade there. This response uses clear notation, the correct terminology, and it shows a really deep understanding of the structural orientation. That right there is how you secure the marks.
Because ultimately, higher-order assessment objectives demand way more than just simple description. Top candidates demonstrate evaluative thinking. They question assumptions, they consider different perspectives, and they actually justify their decisions using the specific evidence provided in the exam prompt. They're operating at the analytical and evaluative levels, not just the basic descriptive level.
So, whenever you are facing a complex 2.2 phospholipids question, I want you to follow this exact procedural framework. 1. Deconstruct the question. 2. Extract relevant data from the stimulus. 3. Select your analytical framework. 4. Execute your answer with clear notation. And 5. Present it all with the correct terminology. Literally lock this sequence into your brain. It's a game changer.
And finally, Section 4, the hidden cause revealed.
Okay, congratulations. You have just mastered the phospholipid concepts, you've fixed your terminology, and you totally know how to build a top-band answer. But there is still one hidden reason you might walk out of that exam room feeling great, only to lose half your marks anyway. You know the biology perfectly, but what if the question actually said evaluate instead of describe? This is the examiner clue that changes the whole shebang. Command words dictate the entire mark scheme requirement. If you describe when you are supposed to evaluate, all that beautiful biological knowledge we just covered is instantly useless, and your score gets capped at a low mark band.
So, how do we fix that? Subscribe to our explainer series, Ace the Exams, at acetheexams_IGCS to excel in your Cambridge examinations. Seriously, head over to our next explainer right now, where we decode exactly how to tackle evaluate questions. Ask yourself, are you ready to stop just describing and start actually evaluating? I will see you there.